9.5, solving quadratic equations using the quadratic formula. So the quadratic formula is a formula that's going to give us the real solutions to any quadratic equation, okay? So for any equation in this format, where you have something x squared plus something times x plus another number equals 0, then x is always going to equal all of this, okay? So let's try this out. So I need my equations in standard form, and this equation is in standard form. Got the x squared, then the x, then the constant, and it's equal to 0, okay? So when I have it in that form, I can pick out the a, b, and c. So a here is going to be 1 because that's the coefficient of the x squared, okay? And then b would be -6. The negative is part of it. It's not just 6, it's -6. And then c here would be 5, okay? And then I'm going to plug in a, b, and c into this formula, okay? So what I like to do first is to just write the equation, and everywhere there's an a, b, or c, I leave blank parentheses because I'm going to be substituting things in for a, b, and c, okay? So I've got, let's see, I'm going to have a big fraction here, so negative b, so negative something plus or minus the square root of something squared minus 4 times something. Okay, so just blank parentheses there. On the bottom I have 2a, so 2 times something, okay? And now I'm going to actually plug in the a, b, and c. So these first two slots would be b's, so that's -6. So I've got a -6 here and a -6 here, okay? Then these two parentheses are a's, those two are both 1. And then the c is going to be 5. Okay, and then I'll start simplifying. So the opposite of -6 is +6, the plus or minus. And then I'm going to do the squaring first down here. -6 times itself would be 36. Okay, and I find that this part is the part that gets the most errors, just because you're multiplying three numbers together. But -4 times 1 would be -4. So then I have -4 times 5, and that's -20. Okay, and then this is all over 2. Okay, I didn't leave myself too much room to do these problems. Probably should have left myself a little bit more, but we can deal with this here. Okay, so let's see, we've got 6 plus or minus the square root. 36 minus 20 would be 16, and that's all over 2. Okay, so I'm going to start working to the right here since I ran out of space. Now the square root of 16 is 4. So I've got 6 plus or minus 4 all over 2, okay? Now some people might leave their answer like that, but we can actually do better than that, because even though I got that plus or minus symbol, I can split this into two paths. X is going to equal 6 plus 4 all over 2, or x will equal 6 minus 4 all over 2. And we can simplify both of those. So 6 plus 4 is 10. This is 10 over 2. And then 10 divided by 2 is 5, so that's an answer, a solution. But then over here, I've got 6 minus 4 is 2, 2 over 2, and then x is going to equal 1. Okay, so I got it in there. It's a little bit of a squeeze, but got my answers of 5 and +1. And you could test both of those out in the original equation. You could plug them in and make sure it balances the equation, and it would there, okay? All right, for this next problem, this is also in standard form, so that makes it easy to pick out the a, b, and c. My a is -3, b is 2, and c is 7, okay? So then I'm going to use the formula again. Okay, I've got -b plus or minus, then I got the square root, b squared minus 4ac. And this is all over 2a. So b here is 2, that's going to go there, and those first two slots, these two slots are the a's, that's -3, and then 7 goes in that last slot. Okay, and then it just simplifies. I'm just using PEMDAS now, so I'm going to start the opposite of 2 is just -2, and I'll do the exponent, so 2 squared is 4. I'll also do this multiplication here, okay? So let's think about this. -4 times -3 would be +12, so I've got +12 times 7. +12 times 7 is going to be 84. Okay, and then this is all going to be over negative 6. Okay, and then I do the addition down there, so I've got negative 2 plus or minus the square root of 88 all over negative 6. Okay, now at this point, if you put square root of 88 into a calculator, it's not going to come out to a nice integer, because that's not a perfect square. Okay, so it doesn't work in the same way it does with the 16. You could do a decimal, but it'd be a decimal approximation. So usually what we're going to do would be simple radical form, but actually I'm glad I just read the rest of the directions, because it does say to go to the nearest tenth. So I am actually going to put that into a calculator. Okay, so I need a calculator to put square root of 88 into my calculator. I know the square root of 81 is 9, so it should be 9 point something. Let's check it out. Square root of 88 is going to be about, we're going to end up rounding this to the nearest tenth, but I'll call this about 9.38 for now. Okay, so I can say x is going to equal about, this is approximated, so I have approximately equal to negative 2 plus or minus 9.38 all over negative 6. Okay, so now what I'm going to do is go down both paths here. Okay, and I'm running out of space here again, but I'm going to do the one path where I'm adding in the 9.38 and another path where I'm subtracting the 9.38. Okay, I'm just going to do this on my calculator. So I'm going to do negative 2 plus 9.38. Makes sense, that's about 7.38, and then I'll divide that by negative 6. Okay, so that was when I was adding the 9.38. I got about negative 1.2 if I'm going to the nearest tenth. Okay, so that's one of my solutions. And then if I do negative 2 minus 9.38, and then I'll divide by negative 6, and I'll round that to 1.9. Okay, and there are my two solutions rounded to the nearest tenth. Okay, all right, let's try another one here. It's tempting to look at this and say, oh, A is 4, B is negative 4, C is negative 1, but that's actually incorrect, because we need to put this in standard form first. So if you go back up here, we need to set this equal to 0. So what I want to do is add 1 to both sides of the equation first. So I'd add 1 to both sides. That's going to make this look like this. And now I can see that the C is actually positive 1, not negative 1 when you put it in standard form. Okay, I didn't have to do that with these last two problems because they were already in standard form, but sometimes you might have to play around with your equation to get it in the right format so you can see what A, B, and C are. Okay, and then it's pretty much like the others. I'm going to use the formula. I like to just set up these blank parentheses everywhere there's an A, B, or C. Okay, first two slots are going to be B's, so that's negative 4 here and here. Whoops. Oh, no, yeah, that is the B. Okay, and then the A's are in these two slots. Those are both positive 4, and then C is going to be positive 1, not negative 1. Okay, and let's start simplifying here. Okay, negative 4 times itself would be positive 16. And then I've got negative 4 times positive 4 is negative 16. And then when I multiply that by 1, still negative 16. And 2 times 4 is 8. Okay, so now I've got x equals negative 4 plus or minus the square root of 0 all over 8. Well, the square root of 0 is 0. So now I've got negative 4 plus or minus 0. And when you add or subtract 0 to negative 4, it just stays negative 4. So this is just going to be negative 4 over 8. I don't need a calculator for that because that's negative 1/2, or you could call it negative 0.5. I guess it has to go to the nearest tenth. So there, that's written as a decimal. Okay. All right. So you can get just one solution. You can actually get no solutions on some of these too. If you end up with a negative number underneath the radical, then there's no real square root to say negative 88 or negative 16. So in that case, you'd have no real solutions. Okay, all right, let's look at a word problem here. It says the number of bald eagle nesting pairs since the year 2000 can be modeled by this function. So x is going to be the year since 2000, and y would be the number of nesting pairs. And it says when were there about 160 nesting pairs? Well, if y is the number of nesting pairs, that means I'm going to take the 160 and put it in for y. Okay, so let's go ahead and do that. I'm going to say 160 equals 0.34 x squared plus 13.1x plus 51. Okay, now I want to solve this for x. And just like the previous problems, I want this in standard form before I use the quadratic formula. Okay, so what I'm going to do is set this equal to 0 over there. I want to subtract 160 from both sides. Okay, so then I've got 51 minus 160, that's negative 109 over here. So 0 is going to equal this. Okay, now there are other ways to solve this. I could graph the related equation and look for x-intercepts, but that would be a pain with these decimals. Also, this doesn't look like it'd be fun to try to factor, but that would be another option. So this is a great time to use the quadratic formula when you have decimals or when you have large numbers. Those are good times to use the quadratic formula. Okay, so let's get to it. So I've got x, and then I've got my big fraction. It's going to be negative b plus or minus square root b squared minus 4ac. It's all over 2a. It's worth memorizing the quadratic formula. If you just do enough of these problems, you'll probably just memorize it automatically, but it might be worth just spending a couple minutes with a flashcard if you need to. Okay, so first two slots are going to be the b's, which I can see now is 13.1. Okay, and then these two slots are a's, those are 0.34. And then this last, the c, is negative 109. Make these parentheses really small, but I got it in there. Okay, all right, so let's start simplifying now. Okay, and I'm going to need my calculator now to figure out what 13.1 squared is. That's going to be 171.61. Okay, and I'm going to do this part as well. Okay, so let's try this out. I'm going to start out with negative 4 times 0.34. And that is negative 1.36. And then I'm going to multiply that by negative 109 times negative 109. So a negative times a negative should come out positive. There we go. Okay, and then on the bottom I've got 2 times 0.34, which is going to be 0.68. Okay. All right, so let's keep going with this. So I'm going to simplify. I'm going to do the addition under the radical. 171.61 plus 148.24. Okay, got it all down to that, and now I'm off screen a little bit. Sorry about that. There we go. So I just did the addition there. Now I'm going to put the radical into my calculator to simplify that. So let's take the square root of 319.85, and that gives me about, I'll call that 17.88 for now. Under the radical still, forgot the radical there. No, that's not, I took the radical, whoops, I did do it right there, whoops. Okay, so I've got negative 13.1 plus or minus 17.88 all over 0.68, okay? And at this point, I'm going to need to split this into two paths, okay? So here, let me move over here. I've got two paths here. I'm going to do the negative 13.1 plus 17.88 all over 0.68, and then I'll do it with the subtracting on top. So x is going to equal about negative 13.1 plus 17.88 over 0.688, or x could equal, that was a negative 13.1, negative 13.1 minus 17.88 all over 0.68. Okay, I'm going to have to go down both these paths to take care of the plus minus. Okay, so let's see if I can get my calculator over there. Negative 13.1 plus 17.88, and I'll divide that by 0.68. So I've got about 7. I'll just call that about 7. And then I'll do negative 13.1 minus 17.88 and divide that by 0.68 for this path. That's about negative 45.6 if I'm going to the nearest tenth. Okay, now let's think about this. This is years since 2000. So x is going to be the years since 2000. So when my x is 7, that's going to be about the year 2007, because that's 7 years after 2007. If I did this, it'd be 2000 minus 45.6, but we're only talking about years since 2000. So we don't want to go back in time. This would be, let's see, 2000 minus 45.6. That'd be about the year 1954. But we're only talking about years since 2000, so I'm going to throw that one out just the way because the way the way the problem is worded, it says years since 2000. Okay. Okay, next page. Let's look at something called the discriminant. There's a lot in this section. It's a big section. All right, so the discriminant is the part in the quadratic formula that's underneath the radical. So it's the b squared minus 4ac part. Okay, and you can use that part of the quadratic formula to figure out how many solutions you're going to have. Okay, how many real solutions at least. So so real solutions are going to be the same as the x-intercepts. Okay, so if you think about, if you had a positive number underneath the radical, let's say b squared minus 4ac all came out to 9. Well, then you've got plus or minus square root of 9. And the square root of 9 is 3, so you've got some number plus or minus 3. So that's going to give you two different solutions when you get a positive number under there. Okay, so we've got two real solutions here. And those correspond to the x-intercepts. Okay, if I had 0 underneath the radical, then I'd be adding and subtracting the square root of 0, which is 0. So that number is not going to change on top then. So that means you get one real solution. Okay, and then sometimes if you've got a negative number as your discriminant, then you're going to be taking the square root of a negative number, which doesn't really exist. So that we say that this has 0 real solutions if that happens. Okay, you could also say it has two imaginary solutions, but we'll get into imaginary solutions in Algebra 2, so we don't need to worry about that for now. Okay, all right. So, all right, let's look at this. We've got this equation here. It says find the discriminant. Now, we could solve this for x using the quadratic formula, but if it just asks for the discriminant, then I only need to do the part under the radical. Okay, so I'm going to use b squared minus 4ac. Okay. And in this equation, the b is going to be negative 3. This is already in standard form. So the negative 3 goes there. Minus 4. A would be 2. And c would be negative 4. Okay? And then I'm going to simplify this. So I'll start doing the exponent. Negative 3 times negative 3 is positive 9. Okay? And then I'll multiply from left to right here. So this is going to be negative 8 times negative 4, because negative 4 times 2 is negative 8, right? And then when I multiply this, negative 8 times negative 4 is 32. Okay, and then I add those together. 9 plus 32 is going to be 41. So that's the value of the discriminant. Okay, now I could solve the whole equation for x to figure out how many solutions there are, but I can also just tell using this little chart. Here the discriminant came out positive, and that means there are 2 real solutions. Okay, so it's a little shortcut if you're not asked to actually solve it, but just asked to find what type of solutions you have and how many, okay, or how many real solutions. All right, let's try another here. So standard form again, okay, that makes it nice. I'm using b squared minus 4ac. B here is going to be 4. A is -3, and C is -2. Okay, so let's do the squaring first. That's 16. And I'll multiply those two. That's positive 12 times -2. Positive 12 times -2 would be -24. Okay, and that's going to come out to -40. That's the value of the discriminant. And since this came out negative, if you go back out to that chart, when the discriminant is negative, we get 0 real solutions because you'd be adding and subtracting the square root of -40, which doesn't really exist. So no real solutions. Okay, let's try one more here. Okay, the discriminant, let's see again, b squared minus 4ac. B is -6. A is 1 and C is 9. And let's start simplifying. Got 36. This is going to be -4 times 9, so that's -36. The discriminant comes out to 0. That doesn't mean there's 0 solutions, so that's a common mistake I see on these. A lot of times people say, oh, discriminant 0, 0 real solutions. But if you go back up to the chart, when the discriminant is 0, you got 1 real solution. And the reason why is because you'd be adding and subtracting the square root of 0. So you'd be adding and subtracting 0 to something, and that wouldn't change the value of it, but you'd still have that 1 solution there. Okay, last page here. Let's take a look. This says find the number of x-intercepts of a quadratic equation. To find the number of x-intercepts of a quadratic equation, what we can do is make sure we're in standard form like this, and then we can use the discriminant and just think, well, if y is 0, that's going to be where the x-intercepts are. Okay, so looking at this example, I'm just going to think, oh, I'm asked for x-intercepts. Well, let's plug in 0 for y. And then this is in standard form, so that means I can see, okay, here a is going to be -1, b is 4, and c is -4. And I don't actually have to solve it here since I'm just finding the number of x-intercepts. I can just use the discriminant. So I'm going to use b squared minus 4ac. Okay, so b is 4, a is -1, and c is -4. Okay, and then let's simplify that. 4 squared is 16. And multiply these together, I'm going to get positive 4. And I'm still going to multiply that by -4. So I got 16 minus 16. That comes out to 0. That's my discriminant, and that tells me that there's going to be 1 real solution when the discriminant is 0. So I would say 1 real solution if we started with the 0 in there, but I'm telling how many x-intercepts. This is the same as the number of real solutions. Okay, so I get 1. All right, so there's a lot of different ways now that we can solve quadratic equations. Okay, you can use square roots sometimes. You can sometimes you can factor, complete the square. Quadratic formula is what we're looking at today. You could also graph. Okay, so it can be a little overwhelming when you're not it just says to solve or solve by any method. Which do you choose? Okay, so here's just some basics. So if I had something like x squared equals 16, I'd just take the square root of both sides. So if you have x squared on one side of the equation and then there's no x's on the other side, just take the square root of both sides. But don't forget there's a positive and negative root. That's what I do. Okay. Now the method that I use the most often is factoring. Okay. So usually when I see a problem like this where there's 2 different x terms, there's not just an x squared in either of these, then I'll try to factor it. And if factoring doesn't work, then I'll go to either completing the square or quadratic formula. Okay. And I'll talk about those, choosing between those in a second. I pretty much never use graphing, although you can, and it's in the beginning of the chapter. But I only do that if I'm forced to, because I think it's just more trouble than it's worth. Okay, so let's try factoring this. So I'm looking at this and thinking, okay, if this is factorable, it's going to factor like this, right? Because if I'm thinking FOIL, x times x is x squared, and now I can try to do a diamond problem to find what goes in the back of the parentheses. So I'm going to put the -3 on top, the b, and I'll put the c on bottom, that's -10. And I'm looking for two numbers that add to -3 and multiply to -10. So I'm kind of just thinking about ways to multiply to get -10. That's two ways, but neither of those add to -3. So here's two more ways, and now I do have one that adds to -3. That's the solution to my diamond problem. That's what tells, it's not the solution to, it's not what x equals, but it's going to be what goes in the back of these parentheses. So I've got a +2 and a -5, okay? And then I can use the zero product property. I have two things multiplied together that equals 0, so either this has to equal 0 or this has to equal 0. So if x plus 2 equals 0, then x equals -2. And if x minus 5 equals 0, then x would equal 5. And I just solved that one, right? So when it's factorable, that goes pretty quickly, and I think that's the best method to use. Okay? If we try to factor on this one, if I'm looking through my options here to multiply to get +5, there's only two ways I can do that. 1 times 5 or -1 times -5, and neither one of those add up to -2. So I can't solve this diamond problem. It doesn't have a solution. That means this is not factorable. Okay, so that means I can't factor. I got to go to one of these options then. Okay, and when I'm choosing between these two, you could use either one of these. These will both work. I like to use completing square when a equals 1. A does equal 1 here, and when the b is even. Okay, you can definitely complete the square if those things aren't true, but it's just easier when they are. Okay, and usually when those things are not true, I'd use quadratic formula. Okay, all right. So I'm going to complete the square here. So that means I'm going to try to create a perfect square trinomial. I explained this in an earlier section, right? But I'm going to move the 5 to the other side of the equation. So I'm going to be subtracting 5 from both sides. Okay, and then I'm going to be looking for a number here, a mystery number, and I'm going to add something there, so I got to add the same thing to the other side of the equation. Okay, now I'm going to do a little side problem here to figure out what my mystery number is. I'm going to use a formula. It's going to be b over 2 squared. Okay, and I'm looking at the b in the original problem is -2, so -2 over 2 squared. -2 over 2 would be -1, and then -1 squared is +1. So my mystery number here is 1. So that's going to be the number that creates a perfect square trinomial on the left side. Okay, so here, let me put this away. That was just a little experiment that didn't work out. But now what I'm going to do is factor the left side of this. Okay, so I'm going to set up a diamond problem, and I should get something times itself. Looking for two numbers that add to -2 and multiply to 1. So 1 times 1, well, that would add to +2, but -1 times itself adds up to -2. So this is going to factor then into x minus 1 times x minus 1, but I'm going to write that as the quantity x minus 1 squared. Okay, and then on the right side, I'm going to do -5 plus 1 is -4. Okay, so I factored the left. The right, I did the addition. Now that I've got this written as something squared, I can take the square root of both sides. Okay, so on the left, when I take the square root, that's going to undo the square. On the right, I got to remember it's plus or minus the square root of -4. Okay, and now I want to set this equal to x, so I want to add 1 to both sides, and you could add 1 to the end. I like to add the 1 in before the plus minus. Okay, now I've got the square root of a negative number, and that doesn't exist. It doesn't have, there's only an imaginary solution to that, which we haven't gotten to yet. So anytime you have the square root of a negative number, we're going to say no solution. So this one has no solution. It means if you graphed the related parabola, it wouldn't cross the x-axis. There would be no x-intercepts. Okay. All right, that's the end of that long section, and I'll see you next time.